This is a reminder that you should feel free to take as much time as you need to write all of the notes down and think about them. Pause the video at your own pace.
What is up, my math magicians? Welcome to Chapter 4. I am your host, Mr. Bergman. If there's anything I can do to make your stay here in Chapter 4 more pleasant, please do not hesitate to ask. Section 4.11, Quadratic Functions. So we got some new terminology to look at here. This is polynomial functions, and here they are. These are examples of polynomial functions. All of these. They are polynomials and they are functions, so therefore they're polynomial functions. Any questions? Great. Leading coefficient. So here's what a leading coefficient is. It's the term that has the highest exponent, and in fact that exponent is the degree of the polynomial function. So highest exponent here is 7. That's why the degree is 7. The highest degree here is 2, and that's why the leading term is 2x squared. The leading coefficient, we'll find out later, is also 2 because of this 2, but the degree is 2, and therefore it's a quadratic equation. The leading term here is 6x to the 4th because the highest exponent is 4. We call that quartic. And here, this is linear because it draws a straight line. We call that linear. The degree is 1 because there's an invisible 1 on the leading term. And in general, you've got a formula for a polynomial function. It can be written kind of like this confusing thing right here. F of x, this is the formula. You've got these terms. Term, 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 term. And then you just keep on going, and then eventually you get down to the constant term, if you have one. Now, if you wanted to graph a function that looks like this, one thing that you might notice, first of all, is that it's basically a parabola that has been transformed. It is x squared, but with a horizontal shift of h, a vertical shift of k, and a vertical dilation of a. Check it out. H is a horizontal translation, K is a vertical translation, A is the vertical dilation. So we're going to have all these parabolas that have been transformed, but they're all just parabolas. So what you can do is you can read the transformation off of the original function. Now, a parabola usually has a vertex at 0, 0. That's the parent function. But when you transform it, the vertex moves. It'll move horizontally 1, 4, so the new vertex is here, and it'll move vertically down 2, so the new vertex is here. It will open up or down, and if the parent function opens up, so if you don't, so if a is positive, as in this case 3 is positive, then you'll see that it also opens up, as we can see in the graph here. The parent function has a line of symmetry along the y-axis, but when you shift it, then the line of symmetry also shifts. So the line of symmetry is x equals 1/4. Now in this case, the vertex is at 1/4, so the new line of symmetry is at 1/4. And in fact, one thing you can do, as you might notice here on Desmos, is that you can type in the function as is and get it graphed, or you could type in the formula. You can type in most formulas into Desmos and get sliders. You've got sliders for these 3 different values, a, h, and k, and you can see if you slide them to the right place, then eventually you get a parabola like this, at the vertex at 1/4, -2. Graphing quadratic functions is going to look like this. If you want to graph f of x equals a parentheses x minus h squared plus k, it's going to be a parabola that opens up if a is greater than 0. That's this right here. If a is greater than 0, it'll open up, and if a is less than 0, it'll open down. It has hk as the vertex, and ax equals h is going to be the axis of symmetry. K is going to be a minimum value, like right here. It's the minimum value of the parabola. It's the lowest number in the range if a is greater than 0, and if a is less than 0, if it's negative, then the k is going to be the maximum value of the parabola. Let's take another example. G of x, negative 3x plus 5 squared plus 7. Well, what we're going to do is we're going to try and do this without looking at the graph, and we can see that the maximum value is going to be 7 because that's where the vertex is. It's at negative 5 comma 7. It's going to open up downward since negative 3 is a negative number. It'll be like an n instead of a u. And then the axis of symmetry is going to be at negative 5. That's where the vertex is. And it's going to be a maximum because it's opening up downward. Let's check it out. Oh yeah, there it is. All the stuff we said is true. Vertex is at negative 5 comma 7. I got all that by reading off of the understanding transformations and reading the values of here. This is h is negative 5, k is positive 7, a is negative 3. If you know those things, then you know everything you need to know about a parabola. Here, the a is 1/2, it's positive, so therefore it's going to open upward like a u. The h value is going to be negative 1, and then the k value is going to be negative 1, so that'll be where the vertex is, and also where the line of symmetry is, x equals negative 1. It's going to be a minimum because it's a u. Graphing f of x equals x squared plus bx plus c. Well, if you wanted to graph this, you could go equation table graph. You could also go another route, and we need to be able to do all of these techniques with a calculator, without a calculator, because they teach us different things. So the strategy is actually going to be to isolate x squared plus bx. If we want to eventually put these into HK format. The end result is the format that we just saw. F of x equals a, well, the a is invisible in this case, times x minus h, or in this case it'll be plus because h is negative, and then k is out here. The way that we do this is we're going to complete the square. In order to complete the square, we want to get just x squared plus bx all by itself. So first thing we do is subtract 23, and then once we have x squared plus bx all by itself, then we do our side work. We take this b value, we divide it by 2 to get 5, we square it to get 25. So the number we need to add to both sides is going to be 25. And once we do that, we realize that this is a perfect square, x squared plus 10x plus 25. And if you wanted to factor it, you would get x plus 5. That's the other number that we find in our side work, x plus 5 squared. Combining these like terms, we get f of x equals f of x plus 2 on this side. And now that we have our perfect square, we can isolate f of x. We can get f of x all by itself again by subtracting 2. And so the three values that we get from this equation are that a is equal to 1, h is equal to negative 5, and k is equal to negative 2. The vertex will be at negative 5 comma negative 2. It'll open upward, and it'll have a line of symmetry about x equals negative 5, which is where the vertex is. And it'll have a minimum value at negative 2, which is also where the vertex is. When we know these things, then we'll do a really great job of graphing the parabola by hand. Let's do this again. With a further complicating fact that we've got an a value of 1/2 at this point right here. So the strategy is going to be to stay the same. We have to isolate x squared plus bx. So I'm going to multiply all the terms on both sides by 2. That'll give me 2. See, the 2 goes from here to here. 2g of x is equal to x squared minus 8x, it used to be 4x, plus 16. It used to be 8. We've multiplied everything by 2. Then I'm trying to isolate x squared plus bx, so I'm going to subtract 16 from both sides. You get 2gx minus 16 is equal to x squared minus 8x. That's the b value that I'm going to do my side work on. Negative 8 divided by 2 is negative 4, and negative 4 squared is positive 16. So, positive 16 is the number that I add to both sides. And once I do that, I do see that I have a perfect square here. X squared minus 8x plus 16 factors into x minus 4 squared. Notice that minus 4 is also the other number that I had in my side work. X minus 4 squared. These happen to cancel out. So in order to get g of x all by itself again, I have to divide both sides by 2, or at least multiply by 1/2. So it comes back over here. G of x is equal to 1/2 x minus 4 squared. Reading that equation, I can see all the important information I need to graph it. A is equal to 1/2 h, as it was at the very beginning. This is unchanging. This is the same a as at the very beginning. A is equal to 1/2. H is equal to 4, positive 4, because here we see x minus positive 4. K is equal to 0. So the vertex is going to be at 4, 0. It's going to open upward because a 1/2 is positive, and it's going to have a line of symmetry at x equals 4. That's where the vertex is. And the minimum value, because it's a u, it opens upward. We're going to have a minimum value, and it's going to be at the vertex of 0. Last one. There's a shortcut formula. If you want to find a line of symmetry, you can do this. You can choose negative b over 2a. So, you start off, you identify what a is equal to, what b is equal to, what c is equal to. In this case, a is equal to negative 2, b is equal to 10, c is equal to negative 23 over 2. The shortcut formula exists because you're always going to be doing the same set of steps in order to get to this value right here. This negative 4, it's always going to be doing this and doing this. And so why don't we just make a formula out of those same steps? Once you know the a, b, and c value, you just take negative b. So 10 is 10. B is 10. So let's make it negative 10 divided by 2a. In this case, negative b divided by 2a is going to be 2.5. So the line of symmetry is going to be x equals 2.5. It's also going to be the vertex, the x value of the vertex. And if you plug in 2.5 into the entire equation of function right here, h of 2.5, you get out a value of 1. So negative 2 times 2.5 squared plus 10 times 2.5 minus 23 halves is going to equal 1. All of a sudden, we've got all the information we need. You've got to be able to do it both ways. You've got to be able to complete the square, and you've also got to be able to use the shortcut formula, negative b over 2a, because they're applicable in different ways at different times. So you can say that the vertex is 2.5. That's what we got from our shortcut formula, 2.5, comma 1. The 1 is the output of the function. That's the vertex. It's going to open downward. We see that the a value is negative 2, so it's going to be like an n. And then x, the line of symmetry, is going to be 2.5 as we calculated. I want you to tell me where the maximum is. You should be able to get it from the vertex. What is the maximum value of this function? You tell me. Write it down in your notes. And then when you're finished that, I'd like you to start assignment 4A1. Copy the problem list. Do the first problem. And I just want to let you know that Thomas Jefferson was an amazing president. At the top of my head, I don't really remember what he did, but he's an awesome guy. So that's your audio check, and I will see you in class.